now I'll introduce you guys to Paula, if you want to take it away.
Okay, yes. Hello, my name is Paula. I'm an AI engineer here in Barcelona. I'm currently working at IAG. I don't know if you know this company, but it's in the airline industry. And I started in the AI world at uni, and I was more specialized in computer vision. But now, also because I'm in this new company, we are exploring a lot of LLMs models. So today I'm gonna talk about this. And I'm also part of a community here in Barcelona that is video tech, that is more related to video technologies, but it's also very nice. So if you come to Barcelona sometime, you could join. And okay, should I present the slides?
Yeah, I'll stop.
Okay.
I can find the button.
Okay. I think.
I don't see the stop. Oh, okay. There.
Okay,
Sorry.
let me try if I can. Okay. Can you see my screen?
Yep.
Okay, perfect. So today's talk is gonna be on how to build a RAG model. So it's gonna be like a theoretical and also hands-on implementation. And so, let me press this so you can see better. Can I press here? Okay. So first of all, well, I already presented myself a bit, but I'm gonna say maybe, well, my studies were artificial systems engineering, that is like telecommunications, and then I did a master's degree in artificial intelligence. And that's why I got my interested in artificial intelligence. Well, actually, it started at university because my internship, I did it in a hospital here in Barcelona, where I started to develop algorithms to detect disease detection on kidneys. So I was like very amazed on how powerful AI can be, and also when you mix it with images. And then I started exploring all of this world. And then I started working on a startup that we did object detection and object tracking mostly, type of algorithms. And now what I said, that I'm most focused on large language models. So let's start with some basic theoretical concepts. I don't know how comfortable are you with these topics, but I guess everyone is pretty comfortable talking about large language models because they are super popular now, that ChatGPT is so like huge. But for like give a brief description about this, large language models are a type of artificial intelligence that they are special because they are trained on huge amount of data, and that's how they are able to understand and communicate in a human language that we can actually understand. These models use deep neural networks, and more precisely, they use a type of architecture that is called transformer, and the transformer architecture was the key on all of this huge development that we have now, which is really interesting for me. And then if we go a bit more like in deep on the presentation, this is what is a RAG, like what is the RAG model. RAG model are Retrieval Augmented Generation models. That is basically a large language model, but you just combine it with a retrieval mechanism. So this is very powerful because when you combine it with a retrieval mechanism, what you can do is that instead of having like ChatGPT, so it's like a large language model that is trained on vast enough of data, but you are not sure which type of data is trained on, you can like train this model with your data. So you can provide the type of data that you want, and the model is going to be able to retrieve it. So for instance, I'm going to put like a real use case on why they are very useful. So my dad, it's a lawyer. So he would love to use ChatGPT, but he's unsure on which data it's trained on. So he may use it, but he always will need to double check the source of the data on like how it's like, if it's the data, like it's this law is still applicable today, or maybe it's like 2023 law. So now it's like there is a new one, and the large language model is providing me a not answer. So if you have a RAG model, what you can do is that you can train it on your documents. So imagine you can ingest all the laws here in Spain, or even in Barcelona if you want to be more precise. And then this model is going to just retrieve information based on your data. So then it's super powerful because you can have your chat that is going to tell you all the answers, but you're sure on if data is correct or not. So next here is like an overview of the architecture of the models. And so here what you can see is, so there is basically two big parts of this model. There is the retrieval side and the generation part. So the retrieval side is everything that you have to do in order for you to look for the good answer. So what you do here is that you have, I think I cannot point with the mouse, but you have on top of the image, you have the documents. And these documents go through a process to be able to save it in a vector database. So there is the parser process that is basically from a PDF file to actually text. Then we have chunks that is basically splitting the text in different pieces so that you can actually ingest it in a large language model. Then you have embeddings that is translating the text to numbers. And then you have the vector database that is where you store all of these numbers. Then what you have is the generation side. So basically you go to the vector database, you rank the best outputs based on your question. So you're a user, you ask a question, you go to the vector database, you rank the questions, and then a large language model is giving the information of your text and is providing an answer that is meaningful to you, that is using human language. So this is like a bit of an overview. And now what I'm going to do is that I implemented like a little code that is like a very easy implementation of a RAG model that of course you can escalate it and make it bigger and more complex, but this is going to be just the few steps that you need to implement a RAG model. And I'm going to go over them so that you can understand and maybe you can also create one yourself. So, well, and if you want to go to the GitHub, this is the link and the code is there. It's exactly the same that I'm going to present. And first of all, some requirements. In this project, I use Python, which is the most common language, I think, for large language models and AI in general. Then I use the LangChain library, that is basically a library that has a lot of functions that makes your life easier to use large language models. Then I use Grok, that is just for me like the way to connect through the API of the models, like big language models. And then we have Quadrant, that is the library that I'm using to create the vector database. So once you have this, we go to the first step of our model that is going to be to prepare the documents. So what you're going to do first is that so in order to create a RAG model, you need to collect some documents. In my case, I created documents using ChatGPT actually. So I created several PDF files. And then what I'm doing in this code is basically I generated an easy function just to extract the data from the PDF file and store it in my variable that is text. Next step that we need to do to prepare the documents is chunk them. I don't know if you're aware, but lots of large language models have a limited amount of data that you can input one at a time. So you need to split the document in different sizes. And there is a lot of techniques on doing this because depending on how you split the document, you can win or lose meaning. So it's going to be easier or harder for your model to understand your context. So for instance, in here, I'm using a recursive character text splitter function, which basically I put as a parameter the maximum amount of words that I want in my chunk. And then I also put the overlap. So an overlap is basically like if I have my text, I can cut one part and then the next one. But if we have overlap, we have this part and then this one and this one. So there is redundancy between the chunks. And this will enable my model to have more context, to understand better where this text is coming from. There are a lot of techniques. This one is easy and it's like it gives you good results. There are other ones that are a bit more complex. That is, maybe you can first call an LLM and create a summary of your text that is very short, and then you can input in every chunk you could input the summary of the whole text and also the piece of the new information. So there are a lot of techniques that are very cool, and I tried both of them, but I think this one is easy, fast to implement, and it gives you enough accuracy to work with your RAG model. And also this function, what it's going to do is that it's from LangChain and it's not gonna just split the text on the it will count 500 characters and it would split the text. But what it's going to do is it is going to look for a meaningful point to stop. So for instance, if you have the end of a paragraph or even a dot, it's going to stop there. But if the text is still very long, it's gonna do a recursive run again and look for the other most optimal point to cut the text. So you ensure that all your splits make sense. And then, so you run this function and then you get the text splitted and you use this. So it's like the points where you need to split the point and then you actually split the documents and create the different chunks that you use the split text function. Next step that you need to do is to create the embeddings. So I think the creation of the embeddings is one of the most interesting parts on this process because it's transforming from words to numbers. So here what you do is that in order for the large language models to understand the letters, you are not inputting actually letters. What you're doing is that you're collecting all the letters that there are, all the letters, words that there are, and you are representing them in a vector space. So for instance, if I create a representation in the vector space of the word queen and king, they are gonna be very close by, even though the letters of them are very different. But if I'm putting the word king and, I don't know, a duck, it's gonna be very far away because the meaning is so far away. So there are different models and they are trained on different data sets. So depending on the data set that it is trained on, it's gonna create one type of vector or another type of vector. So in this case, for this model, what I did is that I used the model that is VGA Small, and it's created from the Beijing Academy of Artificial Intelligence, and it is a model that is like very tiny, but it's trained on all the English language. So in my case, that my documents are in English, it was good enough to run in this model. But for instance, if you have documents in other languages, you should find another model, or you can find maybe a model that is big enough that it can have multiple languages on it. But you also will need to take into account the competency efficiency. So basically, you're gonna call this function and it's gonna translate all of your words, letters, or like phrases into embeddings because it's not necessarily one word, but it can be different type of lengths. Then when you have the embeddings, you need to load them into your vector database. And the vector database is basically a database, but is optimized to have vectors. So it's like it doesn't have much mystery. If you will input vectors into an ordinary database, then for you to look through them is gonna be much harder. And the good thing about vector databases that are preferred for this type of tasks is that you can do a cosine similarity. So basically it's gonna enable a lot of easier tasks when you, I think I'm going to the next slide, but okay, so vector database, it doesn't have much more, it's just a database where you store the data. And then it's interesting because when you have all of your data stored in the vector database, you then need to match it with the query. So you are a user and you ask a question to your model or your chat. And then this database is going to convert this question into embedding, and it's going to look over the database and it's going to find the matches. So it's going to do a cosine similarity. So it's basically going to compare the vector of your question with the vector of all of your answers and find the perfect match. And this is why it's very important to use a vector database. And inside the database, you're going to do the similarity search. Also, there is like another step that is you do first like a ranking of the best. So you do like the ranking of the best answer based on your query, but then you can call a model and do a re-ranking based on that. So it's going to improve the documents, the chunks of the documents that you're choosing to create your answer. The next step on the RAG model is already generating the response. So what we did now is that we are just getting the text. We are preparing all these text, we are creating the chunks, we are saving them on the database, and we are creating the embeddings also for the query. That is your question. And then the next step is to prepare your large language model in order to be able to answer your questions. So here, I don't know if you work with large language model, but the first step is always to create the prompt. So what is important on this prompt? So basically in the prompt, I'm providing information to the large language model on how I want it to act. And in this case, I'm highlighting that it will need to provide answers to a user, and it will have a context that is going to be the documents that are in the vector database, and a question that is the query that the user is going to input. I also highlight that I want this model to only answer based on the information that I provide, but not based on other type of information that it may have. Because for instance, if you are using a large language model that, well, it's actually trained on data, it could go and use his past data that it was trained on to answer the questions, but you don't want that. So you need to put this also in the prompt. And so you put this, and basically it's an easy prompt, but you can see that it will increase a lot your accuracy because it's only gonna answer what it's supposed to answer and not say anything that is made up. So you are decreasing the hallucinations of the models. And the next step is basically here, I'm using the Grok architectures to call the model. In this case, I'm using Llama 3, and it's powerful enough for my case, and I think it's actually pretty powerful, so you don't need a much larger model. And then I'm calling the retrieval QA function that is basically just mixing everything together and providing the answer to me. So now what I'm going to do is that I'm going to show you actually the code that I did. And also I created like a little frontend, but I mean, it's not gonna be super cool because you're the frontend queen, so probably you do amazing frontends, but this is just a way to show you how it actually works. So let me see. Okay, I think I need to drag the code into this screen. Okay, 1 second. Okay. Okay, here. Okay. I think you're not seeing this. Okay. 1 second, because it looks like I cannot move this. So maybe I can stop sharing and share again the other screen. Okay. And now this. Sorry. Share screen. Okay, I'm gonna do a test and let me know if you can see it. Okay. Can you see my code?
We do.
Okay, fine. All right, let me move this because I see only this Zoom chat and I cannot move it. Oh, I cannot move it. Okay. Well, this is the code. I don't know if you see it a bit of small, but it's like an easy short code. Here you have the main file, which basically it's everything is happening. So you have all the processes that I just showed. So here you get all the documents, you do the parsing of the document, you chunk it, you split the text, and then you save everything in an array. Later on, you create the embeddings and load it into the vector database. So this will be everything of the retrieval side. And then you already define your prompt here. And then you prepare the template. You initialize, well, this is just an initialization to call the large language model. And then here you prepare the database, you re-rank, and define your query. Here is the question of the user, and here, if you run this code, you will see the score of each of the documents. Like in every question that you have, it will print the score of each of the chunks, so you know how similar it is to the question that you have. And then the retrieval based on this information is going to be able to make the answer for you. So now, okay, let's see how I can show the model. I have it here. Oh, wait. Okay. Wait 1 second. Gonna stop sharing and share again. Okay, here. Let me share. Okay. Here again. Okay. Okay, again. Yes. Okay, here. So here you can see the frontend that I did. So basically these are all the texts that the PDFs that I ingested. So there is a photosynthesis one, Amazon, rainforest, Japanese cuisine, inflation, economy, and basketball. If here I ask one of the questions, so what is the significance of umami in traditional Japanese cooking and how it is typically achieved? I put this into my code. Oh, it went very fast. So here you can see the question. And here you can see the answer. So I don't know how comfortable are you with this topic, but I read this 100 times to make sure it works. And I know this is correct, that it's the fifth taste and it works alongside sweet, salty, bitter, and this. And then if I could ask more questions about this type of documents, so maybe you can do the photosynthesis one. So you can press this question and it will pop also an answer here. That is the dependent reaction of photosynthesis occurs in thylakoid membrane of chloroplast. I think it's good. And also you can see that if I ask another question, so that is not one of these documents. So for instance, tell me the rules of football. It's supposed to answer that it doesn't know it. So you can see here, I don't know. The provided context and information are about the evolution of basketball strategy, not football. So you can see that you will, if with this easy code that I think it's less than 200 lines, you're able to create a very powerful chat for yourself or even your company, where you can actually train it on your documents and have reliable information based on your context. So also another type, let me go back to my presentation. Another type of use case that I have seen a lot in companies is also that it's very used in human resources, or for instance, in our company, we used it for the legal department because we have a lot of contracts. So it was hard for the buyers to understand which contracts we have in place with different companies and what are the rates that we have. So we created a chat that was enabling them to chat with the contracts and no need to go through them. Obviously, in the company, we implemented like a much harder version of this because we had like thousands of documents. So we need to create like a model that was more scalable. And also we needed to make sure that the data was 100% correct. So what we did is that we created the chat interface similar of the one that I showed, but we also created a visualization of the PDF file. So for each answer that we provided the user, we also showed the page where this information was shown. So it was very easy for the buyers or legal people to double check all the information and make sure that actually the model was working correctly. And so I think that's it. Thank you all for listening. And please, if you have any questions, ask me. And yeah, I hope you like this presentation. I'm gonna stop sharing.
Thank you, Paula. Amazing presentation, and it really looks pretty simple on the way how you are showing how to implement the RAG model. We have some questions in the chat. And the first is, what happens if you ask it a question that involves more than one of the documents?
Okay, so in here, this would be actually one of the limitations because the models work in a way that they rank the documents or even the paragraphs of the document. So it will provide the answer based on the top, for instance, top 3, top 5 documents. So you can have an accurate answer, but maybe, so like you cannot specify how many documents you want to mix on this answer. I don't know if this answers your question. But yeah, you will get a bit of a combination. But in our case, in the company, when we were visualizing the document file, it will only show the first one. That is actually the one that got the most score, like the most matching score with the question. Yes.
Makes sense. We have another question. How do you tweak the responses from the model if it doesn't answer correctly?
Okay, so if it doesn't answer correctly, there are several things that you can do. First one, when you work with large language model, is you touch the prompt. So you make sure that to put like, maybe you need to write 2 times that make sure to only answer questions based on the documents that we enabled you. But it can also be something related to your type of document. So maybe the data that you have is not correctly specified. I mean, in AI, the algorithms are like, the models are as good as the data that you train it on. So for instance, if you have documents that are very messy, it's gonna be hard for you to have a good model. And then also there is the chunking strategies that they add a lot of value. So you could explore more chunking strategies to maybe improve the accuracy overall of your model. Yes. Do you have more questions or did I answer the questions that you had?
Yeah, and the one last question. What resources would you recommend for someone who wants to learn more and get hands-on with building RAG models?
Okay, so there is like I don't know if you know, but there is deep learning AI, like university courses. There is a lot of short courses online that they are amazing, honestly. They are like, I don't know, 15 minutes, some of them, 20 minutes. Like it depends, but you have so many topics and all of them are very like applicable to business, like right away. So you don't need to even like know like the background of large language model or like AI in order to use it. So I will highly recommend these videos. And they are really well explained. And I think they even have with notebooks with the code so that you can even test the code while you're watching the video. So they are very good.
Amazing, definitely worth checking it out. If anyone has more questions, feel free to. Yeah.
Yeah, I had a question. So I work with like a similar large language model type based thing, and I think it is an RAG. Now that I know what that is, but because like it's supposed to draw knowledge from a knowledge bank, but it still tends to like. I guess my question is like, how does this one do with tabular data and numbers and like if it needed to report from like a financial sheet or something?
Okay, so we actually were reporting of also financial sheets. In our case, in the company, we were using ChatGPT 4, and it was actually able to read the tables and extract the values. I will say it was not 100% accuracy. It's much better with words rather than with numbers. And also, when you have different structures in the Excel file, it's harder for the models to read them. So in our code, when we did the text extraction, we had different functions. One was to so like extract text directly. One of them was detecting if there is tables on the documents. And if there is tables, we try to have like a specific mechanism to like extract the data by row. So it will keep the meaning. And also we even were trying with images because some of the diagrams that were in our PDF files were not like a PDF structure, but it was just an image that someone pasted on there. So with ChatGPT 4, it's actually multimodal, and I think there is the option to use ChatGPT 4 and ChatGPT 4 multimodal with the API. So if you use the multimodal one, it's much expensive, but you can actually also read the images and extract context from them. Even though in my experience, we did this, I would say 9 months ago. It was not that good, but I think the model that they have now is very powerful. So maybe it's better and it works perfectly. But for the one that I used 9 months ago, it was not 100% accuracy, but it was pretty good, I would say.
Thank you, Paula.
Thank you all.
I don't
Thank
think
you,
that
Paula.
we have more questions. It was a really amazing session, and thank you for having you.
Thank you all. I love being here. And please, if you have any question that comes to your mind, like at another point, you can also you can reach to me. Here is my email, and you can find me in LinkedIn. So feel free to reach me.
Thank you, Paula. Amazing session.
Thank you.